Okay, so we're here to start. Hello everyone and welcome to the webinar Fractional Efficiency Testing of Air Filters. My name is Sneha Swaminathan from Hollingsworth in Bose and I'm the moderator for today's webinar. Looks like we have a global audience here, so I would like to thank each one of you for attending this webinar. This event is brought to you by American Filtration and Separation Society. The webinar will be of 45 minutes followed by 15 minutes of question and answer session. We would really like to hear from you, so please ask questions and share comments using the question and answer panel on the right side of your GoToWebinar player. Please make sure your phones are on mute, and this webinar will be recorded. At this point, I want to introduce our featured speaker, Mr. Tim Johnson. A brief introduction about our speaker. Mr. Tim Johnson has a bachelor's degree in physics from McAllister College in St. Paul, Minnesota. He has worked at TSI Incorporated since 1978 and has worked with the automated filter tester product since 1990. He is currently a senior application engineer in the Particle Instruments product group. He is responsible for the product applications using the automated filter tester equipment and components used in filter testing applications. Mr. Johnson is also a member of the AFS was a member of the AFS Board of Directors and is actively involved in ASHRAE and SAE committees. Tim, welcome to the webinar. The floor is all yours. Tim? Tim, go ahead.
Okay, I was muted there. Sorry for the slight delay. Thank you all for attending. It looks like we have a real good attendance today. So today I will be talking about fractional efficiency measurements on air filters. Let's see if we can get the slides to advance here. This is just a brief outline definition of what fractional efficiency or fractional penetration is. Brief talk about air filtration mechanisms, and then methods to obtain fractional efficiency, and then the details of the fractional efficiency method. First, what is fractional efficiency? Air filter efficiency varies with particle size, and fractional efficiency is simply measuring the efficiency at a variety of different particle sizes. The result is a curve of efficiency versus particle size, and a unique property of air filters is that there is a minimum efficiency, also called maximum penetration, or commonly described as most penetrating particle size, and the abbreviation MPPS is also frequently used. For air filters, as with any filters, the penetration through a filter is the downstream concentration divided by the upstream. And normally we'd multiply that by 100 to get the percentage. And if you're more comfortable with efficiency terms instead of penetration, efficiency is 1 minus penetration, or 100 times that for the percent efficiency. As I said, there is a most penetrating particle size for all air filters, and on mechanical media, that'd be media such as glass fiber media, cellulose media, things like that. The typical most penetrating size is between 0.1 and 0.3 micrometers or microns. Or another way of talking about that would be between 100 and 300 nanometers. Electrostatic medias especially, but also membrane medias, can have most penetrating particle sizes smaller than 100 nanometers. And in the case of electrostatics, it's frequently around 0.04 microns, or 40 nanometers.